Hi, this is Mrs. Z, and I am going to go over how we are calculating average atomic mass. So remember that an isotope are atoms of the same element. That means that it has the same atomic number, which means it has the same number of protons, but that they are different mass numbers, which means they have different number of neutrons. When looking at a isotope symbol or isotope name, you will see that this number, the top number, and then the number underneath the name is the mass number. They will always give you that. This number 2. Sometimes when you have the isotope symbol, they will not give you this number, which is the atomic number, because you can get that number from looking up the chemical symbol or the element's name. So it's unnecessary for you to have the atomic number. And the numbers that are given are not given to you because, again, that would be redundant. And really all you need to do is look up on a periodic table the symbol or the name to get the atomic number. It's the mass number that's important. Now, the atomic mass of an atom is the actual mass of an atom. So for one specific atom, it has its own mass, right? When you have average atomic mass, by definition, it is the average mass of all the isotopes for that particular atom that's present in the world, okay? And that is what we're going to learn how to calculate. So, So looking here, I have isotopes that are in nature. So I have hydrogen. So hydrogen generally has 3 different isotopes. Okay, so it has hydrogen 1, hydrogen 2, hydrogen 3. For helium, there are generally 2. Helium 3 and helium 4. And then lithium here, you can see lithium 6, lithium 7. Right? So again, as you can see, each number of protons identifies the element, and it is the same number for all of the isotopes. It's just the number of neutrons that are represented here that are always different. So I have atomic mass. How heavy is an oxygen atom? That's the overall question that we will ask, or essentially that you're thinking about, okay? So when we're talking about an atom of a specific element, we're talking about, well, which one are you talking about? When we're talking about average atomic mass, that is what you see, which is the decimal on your periodic table. Okay, it's based off of the abundance, which is the percentage of that particular atom's mass in nature. Okay, so we don't actually use grams, we use the unit of the AMU. Okay, so AMU stands for atomic mass unit, which by definition is defined as 1/12 of the mass of a carbon-12 atom. Okay, we choose carbon-12 because of its purity. So when we're calculating average atomic mass, these are the basic steps. You are going to multiply the atomic mass of each isotope by its abundance when it's expressed as a decimal. What that means is, and then you'll add them together. What that means is, if you're given your percent abundance, you have to change that percent into a decimal by dividing by 100, and then you're going to multiply by the mass, and then you're going to add them up to get the average atomic mass. Okay, and the units would be expressed in AMU, again, atomic mass unit. So here is an example. So this is carbon. So this is all the isotopes of carbon. So for carbon-12, which are 6 protons, 6 neutrons, 98.89% actually occurs in nature, whereas carbon-13, only 1.11% occurs in nature. And then carbon-14, it's less than 0.01%. So when we calculate the average atomic mass for carbon, this is what we calculate, 12.011, which is what you see on your periodic table as your decimal number, because that's the average atomic mass. That's the average of all of these isotopes, okay? So now, so this chart that we're looking at, which is your on your note sheet. So here we're just going to, based off of the information that we're given, again, this just kind of explains. So if these are the only 2 isotopes of nitrogen, Okay, all you're going to fill in here is the actual average atomic mass that you see on your periodic table, which would be the 14.01 AMU. Well, based off of this is asking you which one of these two do you think will have the higher percentage? Well, if the average atomic mass is 14.01, then it would be nitrogen 14. Okay. Looking at these three, again, looking at your periodic table, we know that the periodic table's AMU, or the average atomic mass, is 16.00. So again, the highest percentage has to be the oxygen 16. Okay. Then looking here, again, looking at your periodic table, we know it's 32.07. So therefore, out of these four isotopes, the one that has the highest percentage that you will find will be the sulfur 32. All right, so looking at our example. All right, so we see here that 75.7% is the percent abundance for chlorine 35. Then you have 24.3% for chlorine 37. Okay, so if I add this up, that would add up to 100%, which means that there's only two different isotopes for chlorine. So if we predict here that 35.2 is our AMU, because we're based off of, we have 75%, so we're saying that your average atomic mass should be, close to 35 point something. Okay, so to do it, so following the chart, this is basically what you will do in order to calculate average atomic mass. So we take our percents, we place them here. Okay, then it tells us exactly what to do. We're going to change the percent into a decimal. To do that, we're going to divide this by 100 or move the decimal two places. So it's 75.7 divided by 100, or you take the decimal and you move it two places. 1, 2. So therefore it becomes 0.757 as a decimal. Then you take the mass, which tells us what it is here, and we place it here because that's the isotope mass at this abundance. Then it says product. Product means you're going to multiply these two to get you that number. So 0.757 times 35 is 26.495, which again, rounded. I do the same thing to the other isotope. So I take 24.3 divided by 100, or I move the decimal 2 places, so it becomes 0.243 times 37, because that's its mass. I get this number. Then what you're going to do is you're going to add up the product, and that is the average atomic mass. And the thing that you're supposed to do is basically you check your work by checking, does your answer make sense, by looking at your periodic table to see if you've calculated the average atomic mass correctly. Okay. You are going to complete the practice. I would highly recommend you have me check your work, or you can check it against the answer key, but you are responsible to be able to calculate average atomic mass on your unit test. If you have any questions, please make sure you reach out.